So let's suppose we have a two category. Let's suppose we have a two category, category 1 and category 2. And the probability of category 1 of occurrence of probability of category 1 is the P. And the probability of category 2 will be what? 1 minus P. And this 1 minus P, we are going to mark it as a Q. So what will be the entropy in this case? Entropy will be minus P log of P base 2 minus Q log of Q minus base 2. This is the formula of entropy, and we have clearly mentioned how the entropy graph will be. Means if the probability of category 1 is 100%, then what will be the probability of category 2? Is always be 0, right? So in this case, if we are going to apply the formula, then we have mentioned that entropy will be 0. Similarly, if the probability of category 1 is 0 and means it is the 100%, in that case also we have clearly seen that entropy will be 100%. So, and also we have seen the entropy will be maximum when the probability of occurrence of the event is 50-50 chances, means 1 by 2. So in that case, entropy is equal to 1. That part we have proved. And with this proof, we made this graph, like this graph, and you can see the entropy is 0 in that case. Sorry, if probability is 0, in that case also entropy is 0, and probability is 100%, in that case also entropy is 0. And entropy will be maximum when the probability is 50%. And this is the graph came across, right? So these are the things we have been proved. Now we are going to discuss, we have discussed about the Gini indexing, and why we are learning these terms, entropy and Gini indexing. We are learning this term just because to understand about which node I can select as a primary node. So with this entropy and Gini indexing, what are the end goal? We are going to calculate the information gain. And with the help of the information gain, we are whatever information gain will be maximum, that part we are going to select as a root node. So let's talk about the Gini indexing or Gini impurity, you can say. So according to the Wikipedia, Gini impurity is the measure how often randomly chosen element from the set would be incorrectly labeled if it has randomly labeled according to the distribution of the label in the subset. It is calculated by the multiplying the probability that is given observation is classified into the correct class, and the sum of all probabilities which when the particular observation is classified into the wrong class. So how we are going to calculate the probability? Sorry, Gini indexing. So Gini indexing we are going to calculate with this formula. So let me show you. Yeah. So let's take an example. I can show you the Gini indexing, how we are going to calculate. So this is the Gini indexing formula, but how we are going to calculate, I would request you please take a screen photo of this thing. Just take a photo so that I don't want to scroll up and down. It will be helpful. And also I'm opening this. Yeah, sure. Thank you. If it is taken, then let me also take this. Now, we are going to calculate the Gini indexing or Gini impurity for all the feature. And this problem statement is very simple. The problem statement is saying whether a particular student will stay in hostel or not, right? This is the problem statement. Yes or no, binary class classification problem it is. And there is a two predictor. Number one is the class. Number two is the gender, right? Number one is the class in the sense of in which class you are studying. Gender means like sex. So if it is male and female, so let's take each. So their predictor can be anything. Any predictor can be as a primary node, right? In this case, gender also you can take a primary node, and class also you can take a primary node. So now question is which node I can make it as a primary node. So let's try to understand how the root node is selected by calculating the Gini impurity. We will use the above mentioned data, and we have the two feature which can be used for the nodes like class and gender. We will calculate the Gini impurity. Let me clear this diagram first. We'll calculate the Gini impurity for each of the feature and then select the feature which has the least Gini impurity. Okay. So let's take a first example of class. And in this class, you can see what are the different category of the class are there. Number one category is class 8, 9, 10, and 11. Four category are there, 8, 9, 10, 11. So in class 8, how many students are staying in hostel? So total 8 class category is, you can say three subsets are there, which are studying in class 8, right? Number third row, fourth row, and I think seventh or eighth row. So you can see total 8 class student are 3. Out of 3 student, 2 students are staying in hostel and 1 student are not staying in hostel. Similarly, class 9, out in class 9, 2 students are staying in hostel, 1 student is not staying in hostel. Similarly, class 10 is 1 student is staying in hostel. I am just referring that diagram, this data. Okay, so it is not like that something in hard and fast rule. It's very simple. Just refer the data what you have taken in the phone and just go ahead with that. And you can see class 10 student means whoever is studying in class 10, in that 1 student is staying in hostel and 3 students are not staying in hostel. Similarly, class 11, 3 students are staying in hostel and 1 students are not staying in hostel. So total how many students are there? Total 14 students are there, and the distributions of the data in across the all class is something like this. 8, the students, number of students who are staying in a class 8 is 3, 9, 3, 10, 4, 11, 4. Now let's calculate the probability of yes and no. The probability of staying in hostel is equal to 2 by 3. It should be 2 by 3. Yes. And probability of no is equal to 1 by 3. These things, how I'm calculating, I think you are able to understand, right? Any question? Similarly, for class 9, 2 by 3 and 1 by 3. Class 10, staying in hostel probability is 1 by 4 and not staying in hostel is 3 by 4. And similarly, for class 11, staying in hostel is 3 by 4 and not staying in a hostel is equal to 1 by 4. Again, I'm saying these things you will never get over the Google. I just wrote down on my pen and piece and pen and paper, and I just took a screenshot. I kept it in the slide so that it can help you to understand how the Gini indexing works, right? So now let's calculate the Gini indexing for each category, each subset of the class, right? So class 8, the probability, the Gini indexing is very simple. Gini indexing formula, what we understood the Gini indexing formula. Let me note down this formula. 1 minus summation of probability P of K, where K is equal to stands for 1 to N. This is the formula of Gini indexing or Gini impurity, you can say. The summation of P means different class. Yes, in this class, in this problem statement, 2 classes are there, yes or no. But in future might be multi-class classification problem you are trying to solve. In that case, the probability of multi-class, class A, class B, class C, class D, like this. So in this case, I have 2 category, yes category and no category. And what we are trying to do in this case, simple. So 1 minus probability of yes, probability of no, ka whole square. Okay, I made a mistake. This should be whole square. So probability of yes ka square, probability of no ka square, and the answer is very simple. And how I'm going to get these things? This I'm just putting the value from here to there. You can see 1 minus 2 by 3 in class 8. Probability of yes is what? 2 by 3. So I'm keeping this thing 1 minus 2 by 3 ka whole square minus 1 by 3 ka whole square. And if I'm calculating this value, I'm getting 4 by 9. So Gini indexing for class 8 is equal to 4 by 9. Similarly, I'm going to calculate the Gini indexing for class 9. I am getting 4 by 9. Class 10, 6 by 16. How it is coming? It's very simple, straightforward. And class 11 is 6 by 16. Any doubt till now? No doubt. Now we are going to calculate the Gini indexing for overall class feature. This is the subcategory of class, right? Now we are going to calculate the Gini indexing for overall class feature, right? So the very simple formula, what we are trying to do, let's understand this part. So overall Gini indexing will be number of instances of class 8, okay, divided by total number of instances into Gini indexing of class is equal to 8 plus similarly this I'm going to put this value as a x. I'm going to keep this value as a y, simple. Just try to understand. So y, because this is the simple, into Gini indexing of class is equal to 9 plus y into Gini indexing of class 10 plus y into Gini indexing of class 11. Keep these things here. The value you know, number of instances of class 8 is how many? 3, right? So 3 divided by total number of instances is 14 into Gini indexing of class 8 was, I think, 2 by 9 something. I forget that. 4 by 9, sorry. 4 by 9. And keep this value here. Just I kept this thing, the same thing here. You can see all the things I'm keeping here. So yeah, 3 by 14 into 4 by 9 plus 3 by 14 into 4 by 9 plus 4 by 14, 6 by 16 plus 4 by 14, 6 by 16. And I'm doing the simple mathematics. It's not nothing hard and fast. It's simple at plus minus multiplication and division. Bodmas niyam rule applied. And the last Gini indexing I'm getting of class feature is equal to 404, 0.404. Okay, just remember this point. And now I'm going to calculate the Gini indexing of what? Gender feature. Okay, so in gender we have total two classes, two category, male or female. Number may one male, and the in case of male, how many total students are coming? 8 total. Eight students who are male class, male category. And out of male, 5 students are staying in hostel, yes, and 3 students are not staying in hostel. Similarly, female, for female, 3 students are staying in hostel and 3 students are not staying in hostel. Now coming the question. See, the probability is 1 by 2, 1 by 2. The entropy will be maximum in this case. See, very multiple choice question. Whenever you are going for the competition examination, in that case, it's a straightforward answer. See here, entropy is maximum. Entropy is maximum. Information gain will be maximum. So, आंख बंद करके gender को as a primary node select कर लो. Right? This is a very simple, straightforward answer. But I'm just trying to explain you with the mathematics. So just try to understand each and every step. So you guys should be prepared for any kind of question for the interview. But if you are going for the multiple choice question and you have a very less amount of time, just observe this point. Okay, probability is 50-50%. And we observe the entropy graph. Entropy is maximum when the probability is 50-50%. Entropy is minimum when the probability is 100%. That is very straightforward, right? So now we are going to calculate the Gini indexing for female class 0.5 and Gini indexing for male class we have already calculated, I think somewhere. Yeah, here is the Gini indexing for male class category. Now simple, we are going to do all overall Gini indexing for gender class, and we are getting 4822, and that was 404. Which one is the maximum? Gender is the maximum. Can you see this? Gender is the maximum. Yeah, so in that case, root node will be the class, because the minimum Gini indexing we are going to consider. The class will be the root node, and then gender we are going to make a child node. This we calculated the root node or child node through what? Gini indexing. Okay, through Gini. Yes. So same thing we are going to do with the help of what? We are going to do same thing with the help of entropy as well. I can show you that. Okay. So same example I'm going to show you with the entropy. As of now, just till now, we have learned how we can select the root node with the help of what? With the help of Gini indexing. Now we are going to see the same thing with the help of entropy concept. Okay. So same thing. Out of 14, so out of 14 instances we have. So first we are going to calculate the entropy of overall data. Overall data means how we are going to calculate the entropy of overall. So total, what is our target category? Staying in hostel or not, right? This is our target category. So in this target category, how many yes, how many no? 1, 2, okay, 8 yes and 6 no. So calculate the entropy with the staying in a hostel. So we are going to, it's very simple formula, right? We are going to, okay, what will the probability of staying in hostel and not staying in hostel in this case? Its probability will be 8 by 14, and here will be 6 by 14, right? So apply this logic here. The formula is of the entropy is very simple, right? minus p log of p base 2 minus q log of q base 2. And in this case, our p ka value is what? 8/14. And q ka value is equal to 6/14. Apply this logic here. Minus 8/14 log 8/14 base 2 minus 6/14 log of 6/14 base 2. Calculate these things. If you have scientific calculator, do it. Otherwise, go to the Google and search for scientific calculator. And if you are able to calculate these things, I have already calculated with the scientific calculator, and the result will be this much. 0.985. This is our entropy for overall data. Okay? Now, we are going to calculate the entropy of class feature. Okay? Take your pen and notebook. It will be helpful for you to understand. And in 8 class student, we have 2 yes, 1 no. 9 class, 2 yes, 1 no. 10 class, 1 yes, 3 no. 11 class, 3 yes and 1 no. And we are going to calculate the probability of yes, 2/3. Probability of no, 1/3, 2/3, 1/3, 1/4, 3/4, and 3/4, 1/4. This is the probability distributions. Now let's do these things and calculate the entropy once again. So for the class 8 feature, class 8 ke liye, the entropy is very simple. This. So here the calculation will be bigger. So apply these things in this formula, minus p log p minus q log q. And we are going to apply these things. 2/3 log 2 and class 8 ka entropy will be this. Class 9 ka entropy will be this. Class 10 ka entropy will be this. And class 11 ka entropy will be this. Now, information gain. How we can calculate the information gain? Okay? Information for the class feature. Just understand the class feature. See, the entropy of means total number of classes, 8 class student is how much? 3. So same logic. Total number of instances of class feature divided by total number of instances into Gini indexing was the formula. Now in this case, instead of Gini indexing, we are going to apply the entropy. That's just same logic what we did in the Gini indexing, but here instead of Gini indexing, we are going to apply entropy. So 3/14 into 0.918, all the things you are going to apply here, and we are getting at the final information gain is equal to 0.8574. Okay, 8574. Now we are going to calculate the information gain. So information gain, how we are going to calculate? This is the only additional thing we are going to apply. So entropy, overall entropy, which we calculated here, which we calculated here, overall entropy. Okay? And overall entropy is 0.985 minus 0.857. And we are getting information gain is equal to 0.1276. Okay? And you must ask this question, do we need to remember this much of mathematics? No, you don't need to remember. These are the things where the Python library will come into the picture. Those things is getting done by the Python library automatically. But as a point of interview, you should know how the Gini indexing works, how this library works, how the information gain is getting calculated, what is entropy, how the entropy and Gini indexing can be selected to select the root node, how the things is getting work at the back end, what is the mathematics behind of it. These kind of question you might get faced while giving the interview, so that you should remember how the backend works, right? Similarly, we are going to calculate the entropy for gender class, and in gender we have male class, we have female class. So same, we are going to calculate the entropy here, and female class ka bhi entropy we are going to calculate. And information we are going to calculate, and we are getting 972. Information gain we are going to calculate, and you can see from here the information gain we are getting 0.012, but with that class we are getting 0.1276. So you can see information gain of the class feature is high than the information gain of the gender. So if information gain is the maximum, that class, that feature, we are going to make it as a primary node, and another things we are going to keep it as a child node. Any question in this? So like, yeah, so we understood this. how we are able to calculate entropy and information gain, and Gini indexing is going to help you to identify which node will be primary node and which node will be child node. Now, in case of decision tree, it's very means recent question I have seen in while I was taking one interview and I was asking this question. This question has been recently integrated with the decision tree. That's why that's what I added in my slide as well. What are the different algorithm of the decision tree? And these things I found from the sklearn official website. So, so again, at the backend logic is working the same, but the thing is that how the different algorithm of the decision tree works. So number one is ID3, which is called iterative dictomizer. Let's talk about this, how this iterative dictomizer work. See, in interview, no one is going to ask you the implementation of this about this algorithm, but people are very keen to know whether you know the updated algorithms or not, right? So iterative dictomizer is what it is, the one of the algorithm used to construct a decision tree for classification and use information gain as a criteria to finding the root node. Information gain means ultimately it is using the entropy. Okay. So criteria to finding the root node and splitting them, it only accept the categorical attributes. Means in your input feature should not be, continuous data. If it is not continuous data, then you can go with the iterative dictomizer. Now coming to the C4.5, this is again, it is an extension of ID3 algorithm. And better than the ID3, as it deal with both continuous and discrete value. So you should remember C4.5 is when it is suitable, when your input feature are not in categorical type, it is continuous in nature, then in that case, go with the C4.5. Third category is what? Third category is the classification and regression algorithm, which is very famous and popular, and everyone is using by closing the eye directly this algorithm, which is also known as the CART, C-A-R-T, CART. It is the most popular algorithm used to construct a decision tree. It uses Gini impurity as a default calculation. And in our example also, we will use this CART algorithm. Okay. But however, you can select any algorithm. Like by default, it is selecting Gini indexing, but you can select, there is a hyperparameter, what we call entropy as well, to identify the root node. So this is a different type of algorithm. So ID3 is only applicable for categorical type of data. But if you have both categorical and continuous, then in that case, go with the C4.5. But if you, and by default, it is also using the Gini indexing at the backend to identify the root node. So if you want to, select any kind of means algorithm like Gini indexing or entropy, then yes. So nowadays, no one is going to, wait a minute. Nowadays, no one is using this ID3 and C4.5. Everyone is using this CART. Now go ahead with your question. What your question? Yes. No, ID3. I told C4. See, both ID3 and C4.5 is used for classification problem statement. Classification problem statement means categorical data, but input feature should be, in case of ID3, is categorical type like this. But in this case, C4.5, you can use both continuous and categorical input feature. Let me explain this part. So what I'm trying to say, in ID3, so we have two class and gender, and we have stay in hostel. Okay. So both the category is what? Categorical type, right? These both are categorical type. Input feature is also categorical type and output is also categorical type. Yes or no, right? This is also categorical. So here we can fit ID3. But C 4.5 is what? Just try to understand. Here, class, gender, and stay in hostel. And also we are going to add one more thing, which is called age. Okay? So age is what? Continuous type of data. It can be 4.5, it can be 6, 6.5, 7, 7.5. It can be anything. Age can be anything. So in this case, you can't use ID3. You have to use C 4.5 because this is the categorical type of data. Now you understood. Still so still you are using the classification problem. You are solving the classification problem. But here you can't use ID3. You have to use the C 4.5. Okay, now clear? So in order to, and the problem is again same. C 4.5, the backend, they are using the Gini indexing, but you can't use the entropy. But if you want that kind of flexibility, go with the CART algorithm. CART is very famous. Everyone is using the CART, classification and regression algorithm. It is the most popular algorithm used for constructing decision tree, and it uses the Gini impurity as the default calculation for selecting the root node. However, one can use the entropy for the criteria. I'll show you. You can use the entropy as well to identify the root node in case of hyperparameter, but the things is very simple. So everyone is using right now CART, but as a point of interview my viewer might ask this question: what is ID3, C 4.5, and what is CART? The problem is what? While giving the interview, this term never come in your mind, but it's though it is very simple, right? So just keep these things in your mind. That's what I have added in my slide so that people will never miss this thing. Let's understand advantage and disadvantage of the decision tree algorithms. So advantage, it is used for both regression and classification problem. This is the first advantage. Second advantage, decision tree are very easy to grab as a rule of splitting as clearly mentioned, and complex decision tree model are very simple when visualized, and it can be understood just by visualizing. Fourth is scaling and normalization are not needed. Okay. Disadvantage of decision tree is what? Disadvantage of decision tree, see, bigger disadvantage of decision tree, our tree model based model is very biased type of model. Means why it is biased? Like if your model is predicting more yes, then it will always predict yes, even though the expected result is no. So never go ahead with the decision tree until unless your variance between the input feature is very high. So variance of the input between the input feature should be high, then go with the decision tree. Again, these are the more research and scientific part. Once you will go into deep into the problem, solving multiple type of problem with the multiple algorithm, then you can come up with this conclusion which model can fit on which use case, right? So yeah. Okay, so up to this, any question? Decision tree, we understood how we can build a decision tree. Now we'll come on to the practical session, but before understanding the practical session, let's talk about the one more concept, which is called cross validation. Again, this cross validation is not decision tree specific algorithm. It will be applicable for any kind of algorithm. You can apply in the logistic regression as well, but with the time I will add new term. It is not like that in a single algorithm I will add all the kind of hyper tuning, right? So right now I'm adding cross validation. Tomorrow, if I'll talk about the ensemble machine learning techniques, I will add one more techniques which is called k-fold cross validation. Okay, so these are the things is very common for all the algorithm, right? So cross validation is what? So it's very simple. Whenever we are building the model, what we used to do, it's a very generic problem statement. First thing what we are trying to do, we are going to split our data, right? Split data into train and test. So what we used to do, We used to call the sklearn split and train split the data set algorithm functions, right? And there we used to pass the how much percentage we want. Generally, we used to keep 70-30, 70 for training and 30 for testing. So in this case, what is the problem? So let's suppose this is our whole data, 100 data point. And out of 100, 70 we kept for training and 30 we kept for testing. These are the things we used to do, right? Yes, no. Yes. So in this case, what is the problem? You never going to read this portion, whatever is coming in the examination. So your model might get fail in your testing. So in order to avoid this kind of problem, what we are going to learn? We are going to learn k-fold cross-validation technique. So in this k-fold cross-validation techniques, cross-validation techniques, what we are trying to do. So in cross-validation techniques, so in the first iteration, we are going to make this portion for testing and remaining for training. Second iteration, we are going to keep this portion for testing and remaining this and this for training. Third iteration, we are keeping next part, fourth, and so on. And kth iteration, we are keeping k section for testing and remaining for training. So with this, what will happen? Your model, whatever model will be, your model will learn, yes, will learn all the variations of the data set. So your model failure chances will be less. So again, I'm asking the same question. I'm saying again, I'm pointing this point. This cross validation is not specific to the decision tree. It will be applicable for any kind of machine learning algorithm. Did you understood what I'm saying? So you can apply this as a base rule. So going forward, I will add few more things. But as of now, just try to understand k-fold cross validation. We understood, right? Okay. So now just talk about, okay, now I'm going to talk about the practical implementation. So let's import the library first. Okay, there is a new library you can see, GraphViz. This is the common library which is coming to visualize your decision tree graph so that you can see your graph in your console, how the decision tree is getting made. For that reason, this library I'm using. But apart from this, you can see decision tree classifier is coming from the sklearn, and export graph is coming like what we call to export your decision tree graph into your hard disk. And sklearn tree is basically to visualize your tree. And then we have a this section you already know, train test split, and there is a one thing called grid search CV. I have not talked about the grid search CV, so forget about this term, grid search cross validation. I will talk about this grid search cross validation in coming session, but as of now, forget about grid search cross validation. Grid search CV stands for grid search cross validation, but I will talk in next class. But as of now, just try to understand this. Next, what library we are going to import? We are going to import another library which is called pre-processing standard scaler. And next, we are going to import scalar metric, accuracy score, confusion matrix, ROC, AUC, okay, scalar external 6 and string IO, IPython display image, and these are the for the just purpose of displaying purpose. We are going to import this library. Let me run this trust workspace and Python environment. Oh. So we can go ahead with the base environment and let's run it. Okay, it's running. No module found. Sklearn external 6, I think, is got deprecated as sklearn. So this is the problem. That's what I always prefer, create a isolated environment But let's see. Yeah. So see, it got deprecated. sklearn got deprecated. This is string IO, and new function is 6. 6 is from 6. This string IO is coming directly. Now I'm going to pick one problem statement, which is called wine quality data set. So here we are going to measure the wine quality uh, behalf of multiple feature. Like in case of wine, there is a multiple features are there, right? Sugar content, alcohol content, water content. Behalf of that, we are going to identify what is the quality of wine. So let me read that data, and you can see there is a multiple factor. Even I don't know this factor. That's what domain expert needed. So fixed acidity is how much, volatile acidity is how much, citric acid is how much, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH factor, sulfate, alcohol. And then at the end, we are going to mark it the quality as a 5, 4, 3, 2, 1, 10, and kind of thing, right? This is the problem statement. Now, you can see the data set consists of the following input variable. One is fixed acidity, second is volatile acidity, third is citric acid, fourth is residual sugar, fifth is chloride, six is free sulfur dioxide, seven is total sulfur dioxide, eight is density, nine is pH factor. And pH factor, I think it's, right? It's a chemistry term. And 10 is correct, right? So 10 is sulfates, 8, 11 is alcohol. And output variable gives the quality of the wine based on the input variable. So 12 is the quality. And the quality is scored between 0 to 10. 0 means worst quality of wine, and 10 means superior quality of wine. So here you can use the describe function as well. So So this is the description of the each feature: count, mean, standard deviation, and you can see there is no missing value. Everything is 1.99. So if there is no missing, also you can use the pandas profiling. I think I have already taught about these things, so we can use that. And now we are going to segregate our input and output feature. So this is that, and now we are going to split our data set into train and test, and we are going to call the decision tree classifier. And we are going to, now we have created our model called CLF. Now what we are trying to do, we are going to get the feature name. Here we are getting the feature name, and also we are getting the class name of unique, like 8, 9, 10, this kind of thing, and feature name. So these are the different feature: fixed acidity, volatile acidity, and this kind of thing. And class name, we can see class name is something 753648. So you can see the minimum thing is getting start from 3, then 4, 5, 6, 7, 8. There is no wine which having the quality is 9 or 10, and also 1 and 2, right? Now what we are trying to do, we are going to create a visualizing the data set. Visualizing, and you can see this is a very complex data graph. You can take a print or you can save it as well. So just a minute, let me show you what I'm trying to do here. So here I'm going to export this graph in my hard disk here, somewhere in hard disk with the name of my tree.png. So here we are going to use this export graphics, and here we are going to use our model decision tree classifier, and here we are going to use the feature name, and here we are going to use the rounded true, means this rounded will be true, and also field is equal to true, means like that color will get filled. And here I am going to use the prototype plus graph from dot data, and here we are going to use the dot data, and we are going to export that graph into my hard disk, and I'm going to show you image. So it will take some time. Yeah, it's done, I think. You can see this graph is quite expand image. Let's save it. You can copy this and open in Paint. Yeah, it came here. You can see. I just open in the Paint, and you can see. So our alcohol is going to be considered as a root node. Can you see this? Alcohol we are going to consider as a root node. So why we are going to calculate the root node? You can see Guinea is 0.648 and total sample we have 1 and also you can see value is also given here. So 8, 36, 468, 446, 145 and 16. This kind of value we have alcohol inside of alcohol. And then we are going to calculate, and what we consider alcohol is greater than, sorry, alcohol value is less than 10.35. That value we are going to consider as a true, and then we are going to consider total sulfur dioxide as a root node, and if it is a false, then we are going to consider volatile sulfur dioxide, and we are going to do all the things. These are the things at the back end. And did we calculated that mathematics, that Gini indexing and something? It has done automatically by the model itself. Okay, so let's this. No, it has been done by graph views. Is what graph is something to display. The data is coming from the CLF, means decision tree classifier only. Okay, so yeah, you can visualize this data as well. And now here you can see, let's understand above graph. And just I took the one screenshot alcohol. So again, don't consider just this portion and this portion is same. This screenshot I have taken when I was doing some making this PPT and something for you. So that moment alcohol Gini indexing was coming as 0.648, and total sample is this, and 6.4 in, and the first value indicate the column. So first value indicate the column and condition on which root node has been selected, and further will be splitted. And the second value gives the Gini impurity of the selected node, and sample gives the number of observation at the point of the time present in the node, and the value within the square braces represent the number of observation present in each class output. That is above given figure 8 observation in class 1. So you can see we have total how many classes are there. So you can go to the feature these classes. You can see 7, 5, 3 total. How many classes? 6. So come here, come here, come here. So here also you can see 6. So 8 observation we found of class 7. Similarly, 36 6 observation we found, I think class 5. So like this. Okay. Understood this? With this graph, you can understand, right? What is this values? Yeah. Then the split was made by the basic given condition, and we are going to check the score. It is showing 100%, which is not possible at all. If your any model is giving 100% score, then you can say like it's overfitted data or underfitted model. Okay, so this is not good model. Again, I'm saying. So similarly, we are going to calculate the score for test data set, and we are going to calculate the testing score here also. If it is, so see, it is completely, you can see it's overfitted model. Overfitted model means training ke samay you are performing outstanding in front of me. Whenever you are going for interview, you are not performing well at all. In that case, you can see overfitted model. So now we haven't done any pre-processing. Means in this case, we have not done any kind of pre-processing with our data and neither done any hyperparameter tuning. Let's do all those and then see how the score is getting improved. Okay. So just observe, this is our accuracy for testing, 64 point something. Now, what are the hyperparameters are there? So this hyperparameter from where I am getting. So every time always preferred and recommendable. So whenever you are going to do any kind of algorithm, what are the hyperparameter? This is the official website of decision tree classifier, and you can see these are the hyperparameters. Can you see this? And same thing, I took the copy paste from here only and I kept it here. You can see class weight is none, criteria is what? Gini. By default it is selecting Gini, but you can say here entropy as well. Instead of Gini, you can mention here entropy as well. And max depth, you can mention the depth, means how many layer you want. If you want to mention 2 3, then it will go till there and it will stop there. And if you are not mentioning anything, it will go till depth. Maximum features, a maximum leaf node, means how many nodes leaf node you are asking for. Minimum impurity, sorry, I'm coming at that point. That is coming grid search cross validation. Okay, that part I have not taught yet. I told you, right? With the time, I will add new things. Okay, so that part you can use any kind of model. It's not like that only in decision tree it will be applicable. Like cross validation, you can apply in any algorithms. Similarly, grid search cross validation. That part I will come at that point. So there is a criteria with that will tell you which criteria you have to apply. Is it Gini or entropy? That part I will come at. And again, if this is the job of data scientist, right? So you have to check with all the hyperparameter and you have to come up with the reason. Okay, why we are going to select entropy, why not Gini, kind of thing, right? Yeah. And yeah. So minimum sample leaf, minimum sample split, and minimum weight fraction. These are the definition is already given here. If you can go to the website, you can see splitter, maximum depth, minimum sample is split. What is the definition? The minimum number of the sample required to split the internal node. So that is the thing. So minimum weight fraction, maximum features, and random state. Random state is basically what is the use of random state. So see, this kind of model I am training, I am getting some result. You will train, you will get some different result. So this is the randomized result. So in order to avoid this randomization, you can select some random state where you can pass some value, and that value, if you are also mentioning, you will also get the same result like me, what I am getting right now. So that's what random state is important. So you can go to this website, check the what are the different hyperparameters are there. Okay. Yeah. Now, and also I have taken this C. I just copy paste from that website to here, so that I can keep all those things at the same place. So yeah. Now what we are trying to do, we are trying to do the standardizations. Now we are doing some pre-processing. And again, I'm going to split my data set into train and test. And here I'm doing some PCA. I have not taught yet PCA. What is PCA? PCA stands for Principal Component Analysis. Forget about this term. This is also part of pre-processing. I will talk with the time. Means tomorrow, or means in next class, I will talk about the PC and all the sort of things. But as of now, just try to understand it's a kind of pre-processing techniques. in which we are going to reduce the number of hyper input feature. So that part we are doing. Yeah. So I will forget about this. What is PCA at all? So just leave that part. You without PCA, you just create a model. Until unless I'm not teaching, don't stress on this part. So here now I'm coming at that point. What I'm trying to say, you can see our accuracy got reduced 57%, and initially we were getting 64%. Now it could be possible, you can see there is a multiple hyperparameter we talked about, right? These are the hyperparameters. Now how many hyperparameter you will test? Means there is a multiple permutation combination will be there, right? Maybe some hyperparameter will work with the Gini well, and some will not work with the Gini, and some will work well in entropy, but something will not work with the entropy. So how you can select what are the hyperparameter will be the best fit for our model? So for that we are going to learn grid search algorithm. Again, for this kind of running this algorithm, you need a high computation machine, because what is happening at the back end, just try to understand. Okay, just try to understand this. Focus on my words. So let's suppose we have created this JSON. This is called JSON. Okay, and in this JSON we have created all the hyperparameters like criteria. In this criteria, what are the possibilities are there? Gini and entropy, right? Maximum depth I can give 232, means from 2 to 33, and 1 means 2, 3, 4, 5, like this 31 till 31. Similarly, minimum sample leaf is 1, 2, 3, 4, 9, because one range. If you are going to make 2, then 1, 3, 5, 7, 9, like this. Similarly, splitter can be two category, best and random. You can give all these things. How the grid search algorithm works? Grid search algorithm is trying to build different model like CLF1. First, it will consider Gini, and then maximum depth will be 2, and minimum sample length 1, 2, and it will create a model. Similarly, CLF2 and Gini, and range is 3, means this max depth is 3, and these means different combinations, say model it will get created like this. Similarly with the entropy as well. So like how the human will do different combinations of the hyperparameter, you will build the model, and whatever best model is coming up with those combination, you are going to pick that model. So all those things is getting done by the grid search algorithm. So we created these things, and now what we are trying to do. Acha, did you understood how the grid search works now? Hello. Yeah. So here we are going to pass our model, and here I am going to pass the parameters. What are the hyperparameters? These are the parameter grid search parameter, grid parameter. And here I'm going to pass the n job is equal to -1. So what do you mean by the -1? So right now, whatever processor is coming in the market, that is called multi-core processor, right? It's not single core processor. Earlier coming like dual core processor, quad core processor. Have you heard about this term? Nowadays, whatever machines are coming is called multi-core processor. So what are the processor we have seen? Single core processor, dual core processor, quad core processor, octa core processor, and nowadays coming as a multi-core processor. What do you mean by the cores? So cores is basically CPU. Like in a single motherboard, there is a multiple CPU is going to assemble. So that processing is going to be very fast. So if you are going to mention n job is equal to -1, so whatever processor, whatever core is available inside of your machine, it will use all the CPU at a time. It will use all the CPU at a time, and it will get the result. Otherwise, if it is a single core processor, see this kind of algorithm, if you are running in the single core, it will take much time. Though my system is very high configurable, but in that case also my system will get stuck at that point. So let's do these things. So that's what n job is equal to -1 we are going to pick. Okay, let me run this code. and oh, and I have to run this first. Yeah, so grid search is done. Now I'm going to fit this model, and you can see this will take some time because see different kind of combination it is trying. Are you understanding what I'm trying to say? Also at the back end, I can show you one more thing. See, my system got hanged. It will hang. Uh, so what is called task manager. So if I'm opening, I can open this task manager. Just a minute, my system is getting hanged because at the back end there is a multiple configuration is running, right? So it got hanged. Wait a minute. Let me see whether I can show you performance. You can see how, see here, my 100% CPU utilizing. Can you see this? I have, and my GPU is also getting utilized 17%. Can you see this? I have two GPU and also my CPU is getting completely utilized. Memory is also getting completely utilized. Memory means RAM. So like, yeah, so you can visualize everything. So at the backend, this process is running, so it will take some time. So let it to be run. And I don't know about your system configuration is what, but my system configuration is decent. I'm not saying it's very high configuration, but it's decent one. But still, in this case, also I used to stuck at this point. So whenever I used to run grid search algorithm, it used to stuck at some point because at the backend, multiple jobs are running, like different combinations of a hyperparameter is running, and it will get you the best parameter. Okay, just wait for 2 minutes. I would ask you one question now. So now you are able to build a decision tree model. Can you create an application, Python application, like Flask on Flask, create a Flask application with a decision tree, how we did for the, I think, logistic regression or something, right? We did it already. We have shown you. So see, in my case, it's done and my CPU utilization will also get reduced. Can you see this? It is getting reduced now. Yeah, see, now it is getting reduced 55%. Again, it's 100%, 82%. It will reduce 53%. And my GPU utilization also got reduced. So it is getting reduced with the time. So, don't worry. So I will tell you. So I don't know whether you have a GPU processor or not. So GPU is called graphical processor unit. How the GPU works? So it's a high competition of CPU, means another version of CPU. So here is what like here inside of single CPU only there is a multiple threads are there. It's work as a code only, like a code only. So whenever we are dealing with the multiple means high computation system and we have to enable this CPU, we can go ahead with the GPU processor. Okay, so that's what whenever computer vision or especially NLP related problem statement we are dealing with, we should go with the GPU, not with the CPU will be not sustainable approach. Okay, so whatever gaming laptops at all, these are the things is coming with the graphics only, and yeah, you can go ahead with that. And also if I'm checking what is the best parameter for my model, and you can see the best parameter is the entropy, not Gini. Maximum depth is 22. Now you see how magic it is. You no need to take a manual decision. This is the things is getting done by the grid search, and it is giving you the best parameter, best hyperparameter. And with this best hyperparameter, you have a best hyperparameter now, right? Can you create a model with this hyperparameter? See, I'm going to create a best parameter model. Maximum leaf is 1, minimum sample split is 3. It should be 3. I'm going to give here 3. And splitter is random. I can give best. So now I'm going to create a decision tree again with this hyperparameter. And now I will check the score. Let's see. It's coming 51.66. So here is the things you have to keep in your mind. Let me show you one thing. Control A, Control C, Control M, A, Control Z. Clear the code here. What is my training score? Xtrain. 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 Let's see. So see, my model is not overfitting now. 98%. Earlier 100% was coming. So this problem we get overcome. Means though we have not used all the pre-processing techniques and hyperparameter we used, but still there is a multiple pre-processing techniques we can use. And you can see our test score has been improved. Our test score is not improved. Again, I'm saying it was 64%. Now it's coming 51 point something. So it's not a good model at all, right? So, but still your training accuracy got reduced. It was coming 100%, which is not good at all. Okay. So I'm going to save my model inside of this directory. Save this model. And now I'm going to ask one question now. I'm going to give one assignment, create a web app with this model with the help of Flask. And I have already given the enough things to do, I think. Yeah. Yes, yes. This is the, just a minute, let me give. And also you have to replace these things as well, right? 1 minute. Where's my GitHub page name? I forgot that name. ML model deployment, this one. You have to replace the model, and also you have to replace few more things. You have to replace here as well. Now, if you can go to the index.html, you can see there is a, I think you don't need to replace anything. No, you have to replace. No, wait. These things you have to replace. So, submit button. Only thing is that you have to replace this text area in square feet, and even if you can't work on this, you forget about this, create a API na, at least, so that I can hit from the Postman. No need to do. Acha, you know HTML, right? Do you know HTML? So forget. So you can work on the HTML page, and also we can, if you don't know about the HTML, go with the API, create a simple API, and that API we can call from the Postman, and your function will get tested. Here you can see this pickle file. This pickle file only need to be replaced. That's all. To do it, I think you can do it. That's not a big deal. Yeah. So yeah, this is about the decision tree. Any question in the decision tree? Anything? Classified parameter. Sorry, I didn't get you. Wait. I'm going to give it to you. Are you talking about this? This is the, you. I would request search by yourself, but this time I'm going to give it to you. But please try to search by yourself. These are the things is easy to identify, but let me give it to you. Yeah, I have given you. So next class, I'm going to expect these things by you. Create a web app, and if you are able to create a web app, say congratulations by yourself. I will be happy with it. If you are able to create a web app, take a help with Google. Also, you can reach out to me if you're facing any problem. Don't wait till you're coming to the next class. Over the weekday, also in the night time or sometime in morning, I'll be available. But try to complete before coming to the next class, right? So the things is will be understandable. So going forward, I'm going to explain few more things like, okay, PCA as of now, we are going to discuss grid search algorithms and many things, ensemble machine learning techniques. If you are able to create a web app, things will be easy for you, right? Yeah. Okay. Yeah, that's all for today. Then I will discuss ensemble machine learning techniques in next class. Thank you.